And in this module, we reach the point where we are ready to talk about classes in C#, because C# is fundamentally an object-oriented programming language. And before we can create custom objects that work for us, we have to create a class that defines those objects. So in this module, we are going to learn the C# syntax for defining a class, and we'll also start to explore the fundamentals of what it means to do object-oriented programming. In this module, we're going to define our first class, but you've probably already noticed that our project already has a class defined, and that is the program class. In C#, a class defines a new type, and a type allows me to do things and get work done. So a string array is a type, and a list of double is a type, and even console is a type. And each of these different types that I'm interacting with have different behaviors, and they store different information. So a list of double is all about having a collection of numbers, a collection of floating point numbers, and I can add new numbers into that list. Console, that type, provides methods that I can use to make text appear on the console. So in order to get anything done in the C# language, I typically need to have a type involved. So all of this code that I have to have a collection of numbers and to average those numbers, it's all organized inside of a method, which is in a type. In other languages, you can take code like this and just have it loosely floating around inside of files in any location. But in C#, we just require a little more structure. And in order to write this method to contain this code, I would first need to define a type or a class. Now the question is, why do we need to define a new class? And the answer is, well, I certainly could put all of the code that I need to satisfy our requirements that we looked at in the last module. I could place all of that code here inside of the main method. In fact, I could have dozens and dozens of lines of code, even hundreds of lines of code, even thousands of lines of code inside of this main method. And people ask me all the time, how do you know when to create a new class? And I tell people, you have to look and see when your software is becoming too complex, when you have a method that has too much code inside of it, when you have a file that has too much code inside of it. That's when you should start thinking about, how can I use a new class to provide some encapsulation for the complexity that I'm looking at? Imagine you walk away from this program and you come back 5 months later, and I show you these 5 or 6 lines of code right here from line 13 to 18. And I say, tell me what this is doing. And you have to answer instantly. Well, if anyone has walked away from this code for 5 months, even me, and I look at it, I'd have to start looking at the details of each line of code to see, oh, we're looping through a collection of numbers, we're adding all these numbers to a result, we're dividing by the count. Ah, this is computing an average. So just for these 5 or 6 lines of code, it takes me a couple seconds to figure out what is the purpose of this code. What is it actually doing? If I were to encapsulate this code inside of a better abstraction, like another method that is part of a class, I might see a line of code like this instead. So I might see something that just says compute average grade and passes in the grades. And now let's pretend we're doing the same exercise. Walk away from this code for 5 months, come back, look at line 13 and tell me what it's doing instantly. Oh, I know, it's computing the average grade. That's simple. And that is always what we're trying to do in software development. We're trying to build the right abstraction, have the proper encapsulation, and build the right model to manage software complexity. Because yes, the requirements that we're looking at for this course and this module are very simple, but real-world software is never that simple. We have huge systems with millions of lines of code. If we didn't break that code up into methods and into classes, no one would be able to work on that code and get anything done. So that's what we want to do in this module. I want to build a new class that will encapsulate what we're going to write or need inside of the main method here. And what you'll see in the end is we'll end up with code that is essentially what we have now. It's just going to be reorganized and repositioned to be a little bit easier to work with. And speaking of that code, I'm going to go down here to line 21, and I'm going to delete these lines of code that are saying hello name or just hello, because that's really not the purpose of our program. It's just sort of cluttering things up. And this will allow us to focus on our requirements to build a gradebook. Now, before we move forward, I just want to point out that this is the syntax for defining a class. I use the class keyword, and then everything that is a member of that class or associated with that type will be between the opening curly brace and the closing curly brace. Pretty much every class and every type that you write should be inside of a namespace. If you're not inside of a namespace, you're in the global namespace, and the global namespace is dangerous. We don't know what's in the global namespace. It is completely legal for me to get rid of the namespace here, remove this closing curly brace, And this is legal. Program is now in the global namespace. But what's dangerous is someone else might place a program class into the global namespace, and then I'd have a conflict. I'd have a compiler error. It's much safer to put everything inside of a namespace that you control or that you name, so you're not conflicting with types and classes that are defined by, for example, the Microsoft libraries, which have thousands and thousands of classes. But all of those classes are typically in a namespace that starts with the word system. So just by having a namespace that doesn't start with the name system, I know I'm not going to conflict with any of the built-in .NET types. And yes, you can have dots in your namespace. So it's quite common to have, let's say, gradebook.math, and that namespace will contain perhaps a number of classes that are all related to the math operations for a gradebook. But in this case, all we need is just the simple namespace gradebook. So every type you interact with from the .NET framework is going to be in a namespace. So the list type is in the namespace system.collections.generic, and the console type is in the namespace system. So as I pointed out in the last module, you can write system.console.writeLine, and then you don't need the using statement, but I prefer to never see namespaces in my code. I always want to collect those namespaces into using statements. It just makes the code a little bit easier to read. So here's our first goal. I want to define a new class, let's call it book, that is going to represent a gradebook. And ultimately what I want to be able to do is define a variable of type book. Perhaps I name it book, or perhaps I just use the var keyword for implicit typing. So I want to be able to create a new variable and assign it to a new instance of a class named book. So IntelliSense filled in gradebook there, but I want a class named book. So see if you can come up with the basic syntax that will allow this line of code to compile without an error. Currently, we're going to have an error that the compiler cannot find a type named book. We need to define a new class, and based on the syntax I'm seeing here, I'm hoping all I need to do is say, I need a class named book, and then just provide an opening curly brace and a closing curly brace. So book doesn't have any members, there's nothing associated with it. But this is the minimal amount of syntax I need to make this program compile. So yes, the C# compiler understands what book is now, and it can create a new book that I can interact with. So it's legal to place as many classes as you want inside of a namespace and even inside of a file. But most C# developers follow a convention where we only allow one class per file. In other words, this program.cs file is dedicated to the program class. If I'm going to create a new class named book, I'm not going to put it in the same file as program. I'm going to create a new file for book, and I'll name it book.cs. So let's do that. I'm going to cut that code. I'm going to right-click on my gradebook folder and say that I want a new file and name it book.cs. And inside of here, I can paste in that code. But first, I will make sure that my class is going to be inside of a namespace named gradebook. And inside of the namespace, I can now paste my class. And anytime that I'm writing a new class, I'm thinking about how can this class be the right abstraction for what I need. And building the right abstraction means giving this class the right members so that other developers can understand what it's doing and make sense of things. So what do I mean by adding a member? Well, if we look at the built-in list type, this can hold a collection of different types of objects. So in this case, we're working with double precision floating point numbers, so a list of double. So what can this list do? Well, if I look at the IntelliSense window by just walking up to grades and using the dot operator, I can see a number of methods available to me on this list, methods that I can invoke. I can invoke methods to add a new number, to clear this list, to search through the list. I can also get a count of how many things are in the list. That's a property, not a method. A method I always have to invoke by using parentheses. So that's why with grades.add, I have to use parentheses, and inside of the parentheses, I pass a parameter. Here's the number you're going to add. But when I look at count, that's just a property. I don't need to use parentheses here to invoke a method. I can simply say grades.count, and that produces a value for me. So one of the things to think about when you're building a new type, a new class, is what are the operations, or what is the behavior of this particular class? What are the things that it can do? So it can find stuff, it can add stuff, it can remove stuff, it can sort stuff. That's one major piece of building an abstraction. And then the other piece is what is the state that is going to be stored inside of instances of this type, this class. Obviously, a list is storing data, or what we can call state, and that state is the numbers that I'm giving to the list. So 12.7 and 10.3 and so forth. So a class, you can think of it as consisting of two things. There's the state or the data it holds, and then there's the behavior, which typically acts on that state. The way I want to use a book is I want it to hold the grades that are coming into my application. And then I want to provide behavior that will act on those grades. So behaviors that will allow me to add grades to the book, and behaviors that will allow me to compute the statistics for all the grades that the book is holding. Let's look at how to define behavior next. What I want to do is start adding behavior to my book. So I want to give people the ability to add a grade into the book. And that means my book will need a method. What I like to do is try to picture the method before I actually try to write the method in the class. So how will people use my book? Well, they might walk up to a variable typed as book and say that they want to add a grade and then pass in some value, like 89.1 would be a good grade. Currently, this code does not compile because the book does not have a method named addGrade. Why don't you pause here and see if you can add one? You can already see the syntax for adding a method definition to a class. So this is the main method inside of the program class. You'll need something similar, something that takes a parameter, but the parameter will be of type double. I just want to caution you that you do not want to use the static keyword. Instead, use the keyword public when you write your method addGrade. But just see if you can make the compiler happy. See if you can make the red squiggly go away by creating a method inside of book named addGrade. And the method doesn't do anything yet, and we are going to come back later in this module and talk about what this static keyword means and what the public keyword means that you're going to need to use. Here's how I'm going to add the method. Over in book.cs, again, I want to use the public keyword and then the void keyword because this method is not going to return a value. We will certainly see methods that return something as we work through this course, but the name of the method is addGrade, and then inside of parentheses is my parameter list. So I want this to take a single parameter of type double. The name of my parameter is going to be grade, so I expect someone to pass me a grade, and inside of here will be the implementation for grade. Somewhere in here, I'm going to have to store a grade as a piece of state for an object that's been instantiated from this class. I might also have some validation logic. So typically in a business application, if you take input from a user, you have to validate that input. So I would have to check to make sure that grade is greater than or equal to 0 and less than or equal to 100. I could do that with an if statement or with several if statements. We will come back and add validation logic like that later in the course. But right now, I just want to point out that if we come back to program.cs, we have gotten rid of the compiler error. We now have legal syntax. We've added our first method to the class definition. Next, we'll need to figure out how to store this value as a piece of state inside of the book object. There's a number of different ways that you can add state to a class definition. A popular approach is to add what's known as a field definition to your class. A field looks very much like a variable declaration inside of a class. So just like we have a variable declaration for the variable grades that's going to be of type list of double, it's just that I'm using implicit typing here with the var keyword, I can add a field to my book class named grades that is of type list of double just by using a line of code here outside of any method definition. So if I were to declare a list of double named grades inside of the addGrade method, this would now be what we call a local variable. So grades would only be available when I'm inside of the addGrade method, and that's not what I want. I need a piece of state that this object of type book will carry around with it for the rest of its lifetime. So instead of grades only existing when someone calls addGrade, I need to cut that line of code and place it here inside of the class, but outside of any method. And this is no longer a variable, it is a field. And by the way, with a field, you cannot use implicit typing. So even if I said this is a new list of double, I cannot use the var keyword here. I have to say list of double. And of course, list is in a namespace that we currently do not have a using statement for in this CS file. So when you add a using statement to a CS file, it only applies to that one file. I'm just going to hit Control period and say yes. Please bring in a using statement for system.collections.generic. And now any methods that I have inside of the book class will have access to this grades field and can interact with that field. So I can say, for example, that I want to add this incoming grade into the list that is maintained by that field. So I'm now storing that piece of state as part of my object, and we're one step closer to finishing our requirement. And hopefully you're starting to see that, yes, we have some of the same code that we already wrote. It's just rearranged a little bit differently inside of this book class. Now, assuming you've written the same code so far, why don't you go ahead and press Control F5 or go to the debug menu and try to run with the debugger, and you'll be disappointed to know that there's going to be a catastrophic exception. This exception is the null reference exception. It's a very popular exception in .NET, and it indicates that something is seriously flawed about your program. Something is wrong with your logic. The exact error message here is that object reference is not set to an instance of an object. Let's talk about what that means in the next clip. When we ran the debugger, the null reference exception, the error that occurred, happened here on line 9 of book.cs. All we're trying to do here is add a grade into the list of grades that we're maintaining, and it's easy to look at that line of code and say, how could it fail? We're doing the same thing inside of program.cs, and that worked just fine earlier. But what's happening inside of program.cs and what's happening inside of book, they're two different things actually. Inside of program, notice that this local variable, grades, is a variable that we initialize to point to a new list of floating point numbers. So there's an initialization for this variable. Over in book.cs, we never initialized grades. I never say grades equals anything. And whenever you receive a null reference exception, it's because you're using a field or a variable that has not been properly initialized. Now, the solution to this problem is very simple. All I need to do is initialize grades. It's just a little bit of code. But before I do that line of code, I just want to make sure that we're clear on a few terms. I've been using the terms class and object and null, but let's take a step back and try to understand what those really mean. Think of a class like a blueprint. It describes how I'm going to build objects. So better yet, think of the memory inside of your computer like a big pile of cookie dough. And every class that I define is like a different cookie cutter. So if I pick up the book cookie cutter and I walk over to my computer memory, that pile of dough, I can stamp out cookies with that cookie cutter. Those cookies are objects. And each of those objects that I'm creating with the cookie cutter, they have the same shape, they have the same type. They're all of type book or employee or invoice or whatever class you have used to instantiate that object. That's another word we use for creating an object. We instantiate a class that creates an object. And that's what's happening over here in program.cs when I say I want a new list of double floating point numbers. That action is creating a new object of type list of double. And every list I create, I know I can add numbers to that list. This method is part of the class definition. It's going to be there for every list I create. Just like with book, it doesn't matter how many objects I instantiate by saying new book, every book I create will have a method named addGrade. But it's important to understand that every book, every object can have different pieces of state. Take this example for a second. Let me create an explicitly typed variable, which is book2, and say that that is a new book, and say I want to add a grade to book2, and we'll add the value 90.1. So now I have two different objects that I've instantiated using the book class. Since both of those objects are the same type, I can always invoke the method addGrade on those two objects, but they're going to be tracking different pieces of data, different pieces of state. So this book has the value 89.1 inside, whereas this book will have the value 90.1 inside. When I ask these books later to compute statistics, as long as they have these different values inside, they're going to give me different answers. So they have the same behavior, but every object can carry different and unique pieces of state. So I use classes to create objects. And we would say that this variable, book2, refers to an object in memory of type book. And this book variable refers to a different object of type book. Different object, but same type. Now what happens if I do not initialize book2? Well, if I do not initialize book2, I will have a compiler error because the C# compiler can look at this local variable that's defined inside of a method and say, you have never assigned anything to book2. It's uninitialized. That's going to be a definite error. But what happens if I explicitly assign a value known as null? So null is a special value in .NET. There's a keyword here for it in C#. And null is a way of saying that this variable, book2, does not refer to an object. And if I try to interact with a variable or a field that holds the value null, and I try to use the dot operator to do something with that field or with that variable or with that parameter, I'm going to receive a null reference exception, and there's a good chance my program will crash. Now I want to say there are some advanced techniques that you can use to interact with variables that contain the value null. But in general, if you come across a variable with a null value, you want to avoid trying to use that variable. In fact, there's lots of places that you'll see inside of C# code and regular applications where someone will do a check to say, if book2 equals null, well, in that case, we're going to do something different because we cannot use book2. I will also say that nulls can be such a headache and they've been such a source of errors over the years that there's some new features being added to the latest version of C# that will help to prevent null reference exceptions and help you to avoid those scenarios where you might interact with something that has a null value. I'll talk about those more later in the course after the new C# features have been released. But hopefully now you understand that a class is like a blueprint. I use the class to define objects of a certain type. I use the new keyword to instantiate a class and create those objects. And if I leave around some uninitialized fields, those fields can contain a null value. And if I try to use a null value, I get a null reference exception. That's bad. So how do we initialize grades? Well, one easy way to initialize grades is to simply write an initialization expression here that says, grades should equal a new object which is instantiated from the list of double class. So it's a new list that'll hold double precision floating point numbers. That's one way to do it. I'm going to show you a second approach. So when I use the new keyword, I use the class name here, book or list of double, and then I use parentheses, and it's almost like I'm invoking some method named book or list of double. It looks just like add grade, except there's no parameter being passed. And that's because actually behind the scenes, there is a method being invoked. Behind the scenes, the .NET runtime is invoking a method on my class known as a constructor method. So the idea behind a constructor is that it constructs objects of type book or of type list. And inside of a constructor method, if I choose to write a constructor method, it's optional. But if I choose to write my own constructor method, I can take complete control over the initialization of an object produced by my class. Let me show you how to write a constructor. We're going to write what's known as an explicit constructor because it's actually going to appear in the class. Otherwise, we would have what's known as an implicit constructor, where the C# compiler just provides a constructor for us that does the default initialization. We want to have a constructor that explicitly initializes grades. So I'm going to use the public keyword again because we are writing something that is like a method. But now, instead of using a return type like void or int or something, I'm not going to have a return type. I'm just going to write a method that has the same name as my class, so book, and it's a method, so I'm going to end this with parentheses and then use curly braces to denote the body of this constructor method. So a constructor is just another method on your class, but it has some special conventions. It has to have the same name as your class. It cannot have a return type. And inside of here, any code that I write, so if I write something like grades equals a new list of double, this code is guaranteed to execute when I use the new keyword against this class. And then I can be sure that it will execute before I invoke a method like add grade that will try to use that field. And now let's try to run the program again with the debugger and F5. And now I can go the whole way to the end of the program. I can see the average grade is 17.9. Everything has worked, and we have avoided the null reference exception because we have properly initialized our field named grades. Now we know that book is a variable that is going to refer to an object of type book. And anytime we have an object of type book, we are guaranteed to have an add grade method because that is part of the class definition for a book. So let's add the grade 90.5. We also know that somewhere inside of that book, we have a list of grades. So why couldn't we just walk up to that field named grades and add whatever we want into that? Well, if I try to do that, the code I'm writing has a compiler error. And if I hover over this, I can see book.grades is inaccessible due to its protection level. So what is a protection level? Well, before we talk about that, let's again talk about why are we building a class. We're building a class to provide some abstraction and some encapsulation. We're trying to hide some complexity inside of that class. So again, I'm going to go back to the example where if you leave this program for 5 months and come back and look at these 5 or 6 lines of code, what are they doing? You're going to have to look at each line of code and remember, oh yes, we're computing an average. But if this was just a method call on the book, a method call like compute statistics, then at a high level, you would instantly know when you're looking through this main method, you'd instantly know what is happening on that line of code. Oh, we're computing the statistics. And all of the details and the low-level calculations, they'll be hidden and abstracted behind a method named calculate statistics, We also call that encapsulation. Encapsulation is hiding complexities and hiding details that are unimportant at a certain level. So certainly all of the code that we write is going to be important. We would not get the correct results if we didn't care about all of our code and if all of our code wasn't important. But again, at a certain level, like reading through the main method, are the details of how we're computing an average or how we're computing the statistics, are they important? No, probably not. Just like when I add a grade to the book, if all I want to do is add grades and compute statistics, are the implementation details of add grade important? Do I care if that grade is stored in memory or in a file or in a database, or if we call something over the network to put that number in cloud storage somewhere? No. At some level of programming, all I care about is that I have a book and I can add grades and I can compute an average. That's a method we'll have to add later. But for right now, whoever wrote this book did not want to give me access to the underlying list of grades. So inside of a class definition, these keywords like public are what we call access modifiers. They control the access to this particular member of the class. There's a few different access modifiers. I'm only going to talk about a couple of those modifiers right now. We'll talk about more access modifiers in the future, but one access modifier is obviously public. Public means code outside of this class can have access to this particular method, this particular member. I can add this public access modifier to methods. I can also add public to fields. So if I were to make my grades field public, I am granting access to that particular piece of information, that field, the code that lives outside of the book class. To programming.cs, notice how the error went away. I am now legally allowed to access the grades field. But usually this is not what you want. Typically, you'll find in most object-oriented development, we are very protective of our state. We don't want outside code coming in and just modifying some of the data structures that we're using to store things like grades. Someone might add a grade that is illegal. If we're trying to enforce the requirement that all grades are between 0 and 100, well, I just gave the opportunity for someone to stick in a 101, which is an illegal value. If I force people to always go through add grade, this method to add a grade, then one of the things I can do is add validation logic to make sure that they are passing legal values. The other thing I can do is hide the implementation detail that we're actually just storing these grades in an in-memory list. So I could switch things around in the future and store things to a file or to a database. Now, what happens if I remove this access modifier? Well, that's like using a different access modifier, which is the private access modifier. Private is a way of saying, I only want this grades field to be available to code that is inside of this class definition. So yes, I can legally access that field in my constructor. I can access that field in the add grade method, but these are both members of the class. So it's legal for the code here to access the field. But code outside of the book, that code is not going to be able to get to this field. Let's add another field just for fun. Let's imagine that we want to give every book a name. So this could be Scott's book or the science class book. If I were to do that, I would probably want to store that piece of state here inside of the class. So I would create another private field, and let's call that field name. Now, in order for someone outside of the book class to be able to give this book a name, I have to provide some mechanism where they can pass a string that I use to set the name of this book. One way to do that would be to add a method. Perhaps the method could be called setName. Another way to do that is to require a name when you invoke the constructor. So let's add a constructor parameter. When I do this, as we'll see in just a moment, anyone who uses the new keyword and invokes this constructor will have to pass a name. And inside of here, what I want to do is assign this incoming parameter with the name to my field named name. And that creates a bit of a problem because if I just say name equals name, well, it turns out this parameter, since it's the closest thing with the name of name in this code, is going to hide that field that's further down there. And the C# compiler is basically saying, look, you're making an assignment to the same variable. Name equals name makes no sense. It doesn't know that I mean the field name on the left-hand side and the parameter name on the right-hand side. So how do I take this value and pass it along to the field? Well, there's a little trick to do that in C#. This is a scenario that can come up commonly, and the trick to do that is to use a keyword named this. So the this keyword, this.name. This is what we call an implicit variable that is always available inside of methods and inside of constructors. And you use it when you want to refer to the object that is currently being operated on. So I'm saying this object. On this object, I want to set the name field to this incoming parameter named name. I can also use this inside of a method. So I could say, on this object, go to the grades field and add a new grade. So this is implicitly used whenever I'm accessing a member of the class. And that's why most people will leave off this, because all it will do is just clutter up code. But there are these special circumstances where you're forced to use this if you want to have a field with the same name as a parameter that's coming in. Now when I construct a book, so over here in program.cs, I need to pass along a string, and let's call this Scott's gradebook. That piece of state will be stored and encapsulated inside of the book object. So I've been trying to cover every keyword and identifier and symbol that we have seen in our application so far, but there's one keyword that I haven't told you about, and that is this static keyword. What does it mean for a class member like this main method to be static? Well, first let me describe what is the opposite of static. The opposite of static is to have a method that does not use the static keyword, and this is what we call an instance member of a class. So addGrade is an instance member, an instance method of the class book. And that means whenever I have an object of type book, the addGrade method will be available. These fields are instance fields that are associated with an object of type book. So every time I have a book object, that book object, you can think of it as containing and encapsulating a list of grades and a name. And those two pieces of state are private to that object. Statics are not associated with an object instance. Static members like this main method are not associated with an object instance. Static members like this main method are associated with the type that they are defined inside of. What do I mean by that? Well, let's come down here, and temporarily I want to create a variable named P, and I want to set it equal to a new program object. So I'm going to instantiate this program class, and I now have an object of type program that I'm referencing through this P variable. And now I want to invoke the main method. This requires some arguments. Let me just take the arguments that are passed to the main method and pass them through along to the main method. But this is going to be a compiler error. The compiler error is that member main cannot be accessed with an instance reference. Qualify it with a type name instead. That's a roundabout way for the C# compiler to tell you, sorry, but this main method that you want to invoke, you cannot reach it through an object reference. It is not associated with a specific object. Instead, it is associated with the class named program. The only way to reach the main method is to use the class name where main is defined, that is the type name program. And yes, this is legal code now. I can say program.main and pass along the args, and now my program would run forever in an infinite loop because main calls main. And actually, we wouldn't run forever. Actually, the program would eventually crash because it just keeps calling this method in an infinite loop. Let's look at this from the other direction too. So I no longer need these lines of code, and I do just want to point out that I can comment out these lines by putting a // in front, or if I want to comment out multiple lines, I can use /*, and then where I want the comment to end, I can use // and now everything in here, it's still available in the source code, but the C# compiler effectively ignores that. And then another way to do this, if you need to comment out code very quickly, just highlight the lines of code that you want commented out, and then hold down the control key and press K and then C. That will comment out the highlighted lines. To uncomment those lines, hold down the control key and press K and then U. So now those lines of code are uncommented. What I'm going to do actually is delete those lines, because we're not going to use them. What I want to show you is, what about the book? So currently addGrade is not a static method, and that means if I walk up to the book class, the book type, and try to invoke addGrade, it's not going to be available. But let's try to invoke addGrade and pass along a 77.5. Now the compiler error tells me an object reference is required for the non-static field, method, or property addGrade. So that's the C# compiler telling me you need an object reference. You cannot access this method just by using the type name. That's only available for things that are static. And although this is not what I want to do, what I could do to fix this problem is come over into the book, and I could say, yes, let's make this a static member of the book class. And now all of a sudden, program.cs, this book.addGrade that line will be legal. And yes, in case you haven't realized it yet, C# is a case-sensitive language. So this is uppercase B, the class name book. This is lowercase b, the variable book. And what I have now is an addGrade method that is static, so it's only available through the type name. It's not available through a variable that is an object reference. And over here inside of book.cs, it's important to understand the ramifications of adding a static member. addGrade is no longer associated with an object instance. However, the fields that it wants to use, or at least the grades field, is still associated with an object instance, and that's a problem. Because now the only way to make this work and still have a static addGrade method would be to make the grades field also static. And what does that mean? That means that grades would no longer be contained and encapsulated by an object of type book. Instead, this list of grades would be associated with the class book, the class itself. And the problem there is, inside of an application, there's only one book class, so I can only have one list of grades. It won't matter how many times I say new book. The grades field will not be in those object instances that I create when I say new book. There's only one field for grades, and it's associated with the class. But in the end, all I want to tell you is you have to be very conservative when using the static keyword. Chances are you do not want to use it unless you're in a specific or a special circumstance. In many ways, the static keyword negates the benefits of object-oriented programming because anything that is static is not associated with an object. So I'm going to remove all these static members from book.cs and come back to program. And instead of treating addGrade like a static method, let's go back to the object variable and go ahead and add a third grade into the gradebook that we've created, Scott's gradebook. Now, there are places where static members can be useful, and in fact, we're already using some static members inside of our program. Not only is the main method static, but this writeLine method on the console class is also static. So in order to write to the console, I don't need to instantiate an instance of the console class. Since writeLine is static, I can just walk up to the class, the system.console class, and do a .writeLine. So that makes the writeLine method very easy to use. Here's another place where static is used. Let's say that we want to find the highest grade in this list. In order to do that, I'm going to need to look at each grade as we loop through the grades, and we're going to have to figure out which one is the highest, and that means we're going to have to keep track of the highest value that we've seen so far. So let's create a variable. I'm going to call it highGrade. And what do I initialize this to? Well, I want to initialize this to a very, very low value so that as soon as I look at any grade in the gradebook, that first grade will be higher than the value I started with. Well, it turns out there is a static member on the double type named minValue, and this property, double.minValue, I can reach it without using parentheses, so it's just a property. It provides me with the smallest possible value that you can place into a double precision floating point variable. And that means I'm starting off highGrade at the lowest possible value. So inside of the for each loop, the first number I look at should be higher than that value. So one way to do this computation is to say if the current number I am looking at is greater than this highGrade, so this is the greater than operator. That's an operator that you'll see in many different programming languages. This is a less than operator. This is less than or equal to. This is greater than or equal to. And this is the not equal to operator. What I want to do is check to see if the current number is greater than my highGrade. If so, I want to set highGrade equal to the number that I'm currently looking at. So the first time through the loop, highGrade will be the smallest possible floating point value. So the first number we look at has to be greater than that highGrade. Either that or the first grade was also double.minValue, which should be impossible because our requirements say every grade should be between 0 and 100. Another way to write this would be to use another static member. What I can do is I can say highGrade equals, and there's a math class in .NET. And this math class has many static operations to perform mathematical functions like sines and cosines and to find a max value. So I can say, let's compare or look at the number and look at the highGrade. And what I want you to give me back is the maximum of those two numbers. So now that you know how to find the highest grade, your challenge is to compute the highest grade, the lowest grade, and the average grade, and write those three values out to the console. So we're already displaying the average grade. You just have to add the logic to find and display the highest grade and the lowest grade. To show the values that we need, let's declare another variable which will represent the lowest grade, and I'm going to set that to double.max value, so the largest possible floating point value. And just like we had before, I can say lowest grade equals, and now let's do a math.min. So hopefully you found that operation. What math.min can do is give you the lowest of the values. So if I pass in the number, and I pass in the lowest grade that I've seen so far, that will give me back the smaller of the two. And I'm going to call this low grade, not lowest grade, only because our other variable is named high grade. And I just want some consistency there. So either make this highest grade or change this to just low grade. So down here, this becomes low grade. And now we can write out some results. So let's do a console.writeLine that says the lowest grade is, and use an expression to place low grade into the output. And then I'm just going to copy that line, and I'm going to double click to highlight this word and replace it with highest. So the highest grade is, and the high grade. Now let's run this with Control F5. And of course, we are computing these numbers on the list that we've constructed. So the lowest grade is 4.1, the highest grade is 56.1, the average grade is 17.9. Those all seem like reasonable values because I did add a 56.1 into that list. And so our program seems to be working. But remember, I wanted to encapsulate most of these operations into the book class. So for your final challenge in this module, what I want to see is none of this code. I want all of this to be gone. I just want to see book.showStatistics. Let's call it show statistics or show stats. And your job will be to complete all these computations against the grades that are being added into the book and display all these results. But all of this code will go away. Let's create the show statistics method. And I just want to show you in Visual Studio Code, when I have a method that I'm invoking, but it doesn't exist yet, I can place my cursor on that method, press Control period, and generate that method, show statistics. So it just saves a little bit of typing. I'm going to select that and come over to book.cs, and there is my show statistics method. By default, it's going to have this line of code about throw new not implemented exception. We'll talk about exceptions later in the course. For now, just delete that. It's also using another keyword that we haven't talked about yet, which is internal. We'll talk about that in the next module. I'm going to change that to public. So show statistics exists as an instance method publicly available, just like the add grade method. I'm also going to cut this method and paste it above the private field grades, just because when I organize my C# code, I like to have all the private members together, typically at the bottom of the class, and I like to have all the public members together, typically at the beginning of the class. So now I have a public method named showStatistics, and I just need the code inside to implement that method. So coming back into program.cs, let's first of all remove these two lines of code. That's back when we were using a list directly here inside of the main method. We don't really need that code anymore. Instead, I'm going to take this code that we have, cut it out with Control X, come back to book.cs and paste it in. And I don't think I will need to change anything because we still have grades available. It's just now grades, instead of being a list that is a local variable inside of the main method, grades are a list that are a field inside of our object of type book. So we're going to loop through those grades and compute the lowest grade and the highest grade and the average grade. And now back in program.cs, hopefully you're beginning to see what I mean by encapsulation. So again, picture yourself 5 months from today. You haven't looked at this course or this program in 5 months. Now can you tell me what we're doing in the main method? Well, yes, we're putting together this collection of grades, these 3 values, and then we're going to show some statistics. If all I need is a high-level description of this program, it's much easier for me to figure out a high-level description just by looking at these 4 or 5 lines of code. It's much easier than what I had before, which is all the low-level details of finding a minimum and a maximum and computing an average. It's only if I need details about what's happening with the statistics, what statistics are we computing, only then do I need to go into book.cs, look at show statistics, and now I can figure out some of the details that are happening inside of the program. And that's what encapsulation and building a proper abstraction is all about. So at this point, we should be able to run the program. I'm going to run without the debugger. And I can see the lowest grade is a 77.5, the highest is 90.5, and we have an average of 85.7. All of that seems very reasonable and good. In this module, we saw some additional syntax features of the C# language. We learned how to define classes. We learned how to instantiate objects. We now have a class that defines public instance members like add grade and show statistics. We also have a constructor and some private fields as part of our class. Now, in the next module, we're going to look at testing this class, because in this module, every time I wanted to see if my code was correct, I had to run the program and look at the results. Testing your code provides a number of benefits, but one of the benefits is that you can automate those tests so you don't have to run the program every time you want to see if it's correct or not.